I forgot to do the yellow duck, but that's okay. We are live. So everybody, and I think we are, and Russ Barona, you guys know Russ Barona, don't you? You remember Russ? No, he's out of our Resi group. He was down in the islands where we were making circuit breakers and whatnot. And Russ put a note in saying that we should be talking a little bit about, just spend a little time talking about water damaged equipment because of all the storms coming through, which I think aligns up with a lot of what we're talking about this week, because this is a continuation of Modernization Week. And today's today's focus is on partial discharge, remote monitoring, and protection systems, right? So welcome. We have, this is like a full deck here. We've got Jerry. Jerry, you've been hanging in there since Monday. We got Anatoly. I'm not even going to try the last name there. Alexander Romoshkov. Cool. And Raul Febres or Febers.
Perfect.
I said it two different ways. I love it. I love it. All right. So why don't we do this? Let's start with you, Jerry, again. Just give us a little background of your background and we'll work our way around.
Yeah, awesome. Thanks again, everybody. This is day 4 of Switchgear Modernization Week. So I've been here every single day. So Jerry Danish, I'm the director for Switchgear Modernization at Eaton. I have 22 years experience, industry experience. Started off as a field service engineer, kind of worked my way up to the position I'm in now. And welcome to have you guys.
Awesome. I'm just looking at my CPU. I got to close this down. So give me 1 second, because every now and then, for some reason, I just got to make sure that red goes away, because that means we're a little choppy out there. So I'm going to shut my other computer down. And because I don't want to go to Anatoly yet until I make sure I got a good feed. So give me 1 second, guys. Got too many things open over here. Yeah, and I don't know what it is, but sometimes when you have this computer running with our software and everything, it gives me a hard time with my network.
Yeah, and you're just talking about how high performance, what a high performance computer you had.
I know. See that, and it's yeah, I jinxed it, and I think it was Anatoly that did it for us. I couldn't pronounce his last name. Is it Celeber?
Yeah.
Oh,
that's right.
Look at that. Just the way it sounds, it's pronounced. All right. So that looks like, I think, let me close my SKM too. All right. Why don't you, Mr. Celeber, why don't you introduce yourself? Give us a little bit of your background. Anatoly.
I was born in Russia, in St. Petersburg, former Leningrad.
Oh, wow.
And I arrived in America in 1994 and worked in this team starting in 1998, when it was start to be. So I graduated University of St. Petersburg in 1962.
Oh boy.
Then I got PhD, and my main specialty it is measurement technique, electronics, and it's all.
Excellent.
Oh, maybe I can add about myself. I widower. I live alone. but I have my son and his family, my granddaughter, and grandchildren.
Wow.
I'm old enough. I'm 82 old, so.
Excellent. Excellent. Well, I tell you, we're glad we got you on board because I know you probably forgotten more than we know about this stuff.
Maybe.
Maybe. How about you? How about you, Alexander? Where are you out of? What's your background?
I'm from Moscow. I was graduated and got master degree from Moscow Aviation Institute as mechanical engineer. I started my career in Mil Helicopter Design Bureau, mostly working with data and flight analysis and developing software for different applications. In 92, I switched the company. It was Diax, which was working within Russian nuclear power industry, developing different kind of diagnostics. And then it became a daughter company in USA, Diax International, and later renamed to IPDT. And then it was acquired by Eaton, and I started working on Eaton since 1998. And formally, this is my second place in my work career.
Wow.
Well, then that's it's in short working mostly with the software development and support of customer on that area and the communications as well.
Yeah. So a good software background and diagnostics, right? Because what we're going to be talking about is the whole concept of being able to predict a problem and being able to look at data and determine maybe the next steps. Is your expertise in the partial discharge or?
Not exactly. I'm involved in partial discharge measurements, but I'm mostly on data presentation, support manipulations, not the diagnostics itself. I'm not an electrical engineer from that perspective.
Okay.
So that's I handle data, but I'm not making the conclusions on that.
Gotcha. Excellent. Well, welcome to our program. We're going to have a great discussion over the next hour or less or more. We'll see where we go. And then we've got Raul. I said your last name twice, two different ways, and you went perfect.
It's Raul Febres. So.
Raul Febres.
Yeah.
Okay.
I don't speak Russian, but I do speak Spanish.
Muy importante.
Yeah, and it's always a pleasure to work with Anatoly and Alexander. You learn something every time you speak with them. So, I'm an electrical engineer. I have been working with partial discharge for 20 years now, and every time with medium voltage and high voltage equipment. That's why I land here in Eaton, and I start with the partial discharge remote monitoring team 4 years ago.
Okay.
And partial discharge is what I like to do, and I enjoy doing it. I live in Texas, so when I'm not working, I'm grilling and smoking.
Wait, when you're not working, you're what?
I'm grilling or smoking.
Grilling or smoking. Okay. So yes. You're a barbecue kind. Now let me ask you: when you're smoking, what do you like to smoke? Is it pork? Is it what is it?
Meat, brisket. Brisket most of the time. Yeah.
Okay. All right. And we got Tamaki. Okay, Tamaki says, "Good afternoon, gentlemen. Prabet. What's Prabet?
Like hi.
What?
Hi.
Oh, it's hi. Okay. All right.
Just agreed.
All right. Thank you, Tamaki, for joining in. And Tamaki's out of Japan, so you guys know we're across many continents, I guess you would say, different countries. So, but before we get started, I do want to again remind everybody that water damaged equipment. So here in the U.S. and I know in South America, south of the border too, we experienced a hurricane that came through, probably damaged a lot of equipment, went up through the coast. We've got a lot of what do you call it? We've got a lot of water, probably, flooding going in, even in Pittsburgh and all that good stuff in and around the area, just due to a lot of rain and whatnot. So we have NEMA publishes a water damage report. And I will say that if you just go to, you can Google it, NEMA Evaluating Water Damage Electrical Equipment. It's a great free resource. And this, what do you call it? Tuesday, next Tuesday, I am going to have a program with the Ieee, where I will be working with Tim McClintock, who is our NEMA field rep, and we're going to be talking about what are the resources that the electrical industry has for water damaged equipment, and a lot of what we're talking about all week, right, Jerry? We're talking about taking existing equipment and getting it revitalized, extending the life, which may include the whole concept of, if you have water damaged equipment, on how to deal with that in your application. So a lot of what we're talking about this week is very pertinent to what a lot of the country is experiencing with regard to these storms and whatnot. So.
Yeah, and just to add on, Tom, there's obviously with the hurricanes and the flooding and water damage, if there are customers out there or consultants that are working with customers or anyone that needs the information, we are starting to get requests in now for reconditioning of water damaged equipment. So it's critically important that you need assessment of your gear to reach out to us. We can help you with that and get a plan together, get your system back back online.
Yeah, absolutely. And please, I mean, I had some water damage in my house, and I know it's a residential application, but it's very easy for people to want to get back energized and skip some critical steps that could put lives at risk, could put your electrical workers at risk, it could put your infrastructure at risk. So don't try to rush to get things back up and running. Think about it, get an expert in to do it, help you do an evaluation. So I would just plead for that. And there's a lot of resources. If anybody out there has any questions on that, they can email myself. There's resources. If you go up to NEMA and you go to, you call it the NEMA Field, FIELD rep program. There are 4 NEMA field reps. You have a Southern, you have a North. So I'll just go down through the list. You've got Mike Stone, who is out there on the West Coast. Mike is a great resource. All of his contact information is right up there on NEMA's website. You got mike.stone@nema.org. We've got Tim McClintock, who's the Midwest, and these are the states he represents. And we have Brian Holland, who is at the Southern area, Southern field representative. And then we've got the one and only Jack Lyons, who is up there in Massachusetts. And all of his information is available on the NEMA website. So these are a great resource for the electrical industry. These guys do code adoption, and they fight the battles for code adoption. They work, and what's really nice about it is they're a generic resource that can give you NEMA materials like the water damaged equipment. Very great resource for the industry. So mark their names down, understand who your NEMA field rep is, send them an email. And if you want an Eden contact, you can contact myself, let me know, and I will be more than happy to funnel you in the right direction, especially in these times of emergency. So be careful, always do the right thing when it comes to your electrical infrastructure. It's about saving lives, right, Jerry?
You got it.
Excellent.
You got it.
All right. So today's discussion is on partial discharge, and we're going to talk about remote monitoring. But partial discharge, I don't know who's the best person to give us an overview on what the heck is partial discharge. I mean, why don't we go fully discharged? Is my question.
If you go fully discharged and it's uncontrolled, then you have real problems. Put it that way. But yeah, partial discharge, and I'll kick it off. And Tom, I kind of told you I'm not the expert here, but I'll spew my knowledge on partial discharge. It's a localized small discharge of electricity, right? It doesn't completely bridge the electrodes, which meaning, it doesn't go a phase to phase, not a complete phase to phase failure or phase to phase fault or phase to ground fault. It's small little sparks inside insulating material. And you can see that in the pictures right there. Some of the things that you would see in, medium voltage switchgear or, medium voltage motor control centers is that bottom picture shows, I believe that's a potential transformer, but it has the treating effect or that black carbon where the voltage, that's been contaminated by, whatever oil and dust and, different environmental items where the voltage potential is starting to break down that insulation.
And is that tracking over top of the insulation or is it going through the insulation? What's
a little bit of both.
A little bit of both?
Yeah. So the easiest route is across the top of the insulation, but it's been cases where it goes through the insulation too.
Okay,
and you'll see that especially in like cables.
Yeah. That's in fact, I don't mean to cut you off there, but it just it reminded me. I remember when I was working at Crystal River Unit 3, which is a nuclear plant down in Florida. I did some investigation of this and tried to learn a little bit more because we had some concern about some conductors. And I forget what they called that, but there's like trees within the conductor insulation that where the I don't know if is it current that's flowing through there or is it just a voltage potential that's causing the breakdown of the insulation?
So it's a little bit of both. It's kind of erosion of the insulation due to a lot of it's just age, right? And you could probably do a whole segment on cable structure from the old XLP insulation, the ERP insulation. Yep. But that's part of it is that when this stuff gets old and there's no perfect insulator out there, right? So eventually all this stuff breaks down. And that's why we recommend maintenance to keep it in good working condition. But eventually, it needs to be looked at. So, and the top picture shows a little bit more of a breakdown. That's due to corona. And you'll see this a lot more common in electrical switchgear that has moisture in it. And that's just the the insulation breaking down that creates that white powder in between the phases.
Oh, I thought maybe that was like some sugar or powdered sugar we put on there.
No, yeah, that's a perfect insulator.
That's a perfect insulator. I like it. So that powder, is that, now I've heard with conductors, there's a material they called it, was it an elasticizer or something like that? That if you overheat it, you can produce it's almost like a liquid that comes out of the conductor. Is that like something that's coming out of the insulation that's like a liquid that turns into a powder, or is that material coming from around it and it's accumulating on it? Do you guys?
A little bit of both, right? So that's the breakdown of the insulation. Okay. And also with the oxidization, ionizing of the air around it, it creates that white powder. Yep. Okay.
All right. And you're saying, can we detect this?
You're absolutely correct. Yes. Yeah. With partial discharge and the InsulGuard relay, and where we put the sensors, we can proactively sense this this partial discharge. So this is a proactive, measurement of your electrical system in case something would start to go wrong, right? Because if you look at these cases or these two pictures, typically you don't see these day to day, right? You only see these when you can take a shutdown. So if your shutdowns or your maintenance intervals are a couple of years in between, then the best case scenario, or then one of the reducing that risk, is to have the InsulGuard relay, which is an active monitoring system.
So you're not looking at if I see this on my equipment, is it too late?
No.
Okay.
No. When it's too late is when the equipment shuts itself down.
All right. An unintended rapid disassembly in the field.
You got it.
Okay. I get you.
Definition.
It's a definition. That's a technical term. Yeah. And I think that is a Dan Neeser term. Okay. So this technology, is this something that our two Russian friends work on? Is this like the data and looking at this? Is this what you guys do?
So Anatoly and Alex, you guys know the history a lot better than I do behind this product.
It is a long his history, and I think it started not in Russia, the partial discharge study, but probably in America and in Europe. And in USA, it is a very famous person, is Gregory Stone, who started partial discharge before we started.
Mm. Okay. Mohammed is asking, what type of facilities do you generally see this happening? Can you characterize this like in a specific type of facility, or is this just generic for any type of equipment?
Any type of equipment which work with voltage higher than 3 kilovolts. Any equipment. It can be motors, switch gears, transformers, cables again.
And essentially, I have to say that this is pretty normal to have partial discharge in insulation. It's just pretty common. It's not something, if you have partial discharge, it doesn't mean it will break down immediately.
Okay.
The story is about how intense is it and how long it would last when it's developed. It's not unusual, just pretty normal. You can see it practically anywhere. Raul, correct me if I'm not right, but I believe that's what it is.
Muted.
Microphone.
There you go.
You're on, there he goes.
You could have equipment with a low-level partial discharge, and that could be working for years, you know? And like the picture with the white powder, that is a motor winding, probably, yeah. So in motors, because the design and the space that you have there, you always have partial discharge. And they design the insulation to withstand that. The important thing is to follow a trend and to see if the trend change or something affects the motor, and then you kick an inspection. But this powder is typical for a motor, and the important here is to follow the trend during the years. So as they mentioned, this is not one day to another issue. It has a different history. For example, if you have a bus duct out there, and suddenly you have partial discharge there, probably it's coming from humidity coming inside the bus duct. In those cases, you need to act faster because it could be ending a failure in a few weeks or months. So everything depends in the asset that you're looking at.
Okay, and so I think so. What I've learned here is above 3,000 volts is a critical. So I'm not going to see partial discharge on a 480 volt application. No. Okay. And I guess I'm just going to go out on a limb because of the higher voltages and the potential difference across insulation. You're going to get that when you say partial discharge, what you're, and correct me if I'm wrong, it's almost like a leakage current that's going through the insulation.
Well, it is not leakage current.
It's not leakage current? Okay.
It is, again, it is a little spark which occur in the void inside insulation and on the surface of the insulation when there is, how to say, heterogeneity of the structure.
Okay.
When the different type of insulation,
some contamination possibly or inclusions.
yeah.
Okay. And Mohammed is saying, so this isn't something the protective device or relays can detect. We have a relay, right? So there is not a standard like a 5051 relay, an overcurrent protective device. This is a special device that is designed to detect this. Is that a correct statement?
Well, yes. It is not relays. I prefer to say that it's diagnostic equipment. Relay usually should control some device, and if the measured parameter is exceeds some threshold, relay should operate and change the some mode of the device work. Our InsulGuard and partial discharge measurement instrument, it's diagnostic. And unfortunately, there is no defined thresholds to say that it is necessary immediately stop device to work.
Okay. So this is more of a monitoring system that sends a flag up that tells you, hey, you've got to look at this. It doesn't necessarily trip something.
Correct. Correct. And the value of InsulGuard is it provides long-term monitoring, recording data, and what should be causing the most worries of the end user is kind of quick change in trendings. That's the time when you have to take a look at the device. If something is changing and changing quickly, and in both directions, decreasing the partial discharge activity or increasing them, both could have a reason of insulation degradation. So that's what it is.
Okay. So, and I see in here it says electromagnetic pulses, light emissions, ultrasound waves, and electrochemical reactions. Those are the things you're monitoring?
Electrical pulses.
Electrical pulses. Okay.
There are also some diagnostics equipment, but not ours, that are using ultrasonic ultrasonic detection, but not us.
So what are we looking at here? This sensor that's in the top right side. What are these? What's this guy here? Is that just a CT or is that something different?
Yes, it is a current transformer, radio frequency range. So it works. No, particular this current transformer should capture the partial discharge in frequency range from 1 to 20 megahertz. Really, partial discharge is very short pulses. The duration should be measured in nanoseconds, some nanoseconds or some dozens nanoseconds, and they have very wide spectrum. And to measure them, it is necessary to have instrument which will be more protected from noise. And because in frequency from 0 to the 1 megahertz, in industrial environment, noise is high enough. And to be protected from noise, our instrument works in a range from starting from 1 megahertz to 20 megahertz.
Okay, so it's very similar. Like in the residential world, now I'm going way down in voltage. We have what we call an arc fault circuit interrupter that looks at different frequencies outside of 60 hertz, and it tries to detect a problem in the circuit. You're doing something similar, except you're looking at much higher radio frequencies, and you're detecting a problem in those higher frequency ranges.
Yes.
That's sweet. And now Muhammad is asking, how long do you need to monitor the equipment before capturing an event, or I guess before determining that you have a problem? Is this something I can put on today and wake up tomorrow morning and say, okay, I've got a problem? Or do I have to wait 6 months, 1 month?
Usually deterioration of insulation it's enough slow process. So we should continuously monitor the condition of the insulation and see, is it the partial discharge stable in this insulation, or it is not stable. Again, as it was told before, the partial discharge, it is nature of the process in insulation, because any insulation has voids inside insulation. Right. And when the voltage not high, it doesn't happen. But if the voltage became the higher, we have small sparks in this insulation and carbonization of these voids. And it leads to increasing these voids. And the partial discharge will be increased also. But it is a long process. Sometimes when we know that equipment can work up to 20 years or something like this. So, but it depends on the quality of the insulation.
Interesting. So this is the long game.
Yes.
Interesting.
Yeah. And I think the idea is that you don't want to capture event. That means your power system is doing well, it's healthy.
Right.
So when you start capturing events is when you need to take action and shut it down to isolate it and fix it.
So is this something that I can retrofit into an existing piece of equipment that's been there for 5 or 10 years, or is this something that you would only install on new equipment?
It's both.
Both.
We can. We can put it on new equipment, and we can get it on an installed base that's already been been in the field for many years.
The answer to every one of my questions, Jerry, is always both.
Yeah.
Jeez, did you see that, Raul? Okay, so Felix Sandoval, Columbia here, is not South Carolina, South America. Is there any standard for testing or evaluating partial discharge in equipment? That's a good question. What are the standards? Do you have any slides on that one?
No, we don't have, but of course there are standards to measure partial discharge.
Okay, so
it is common standard and special standard, as for example for rotating machines.
So there is, is it an IEEE document? Is it a UL doc? It's an IEEE, Raul?
Yeah. We have IEEE standard for partial discharge measurements, for example, in laboratory during factory tests. And we have some recommendations in the equipment and the process to do in the field. But we don't have yet, at least on hand, but what people is always looking for is what is the maximum value for the partial discharge, for example. And outside of laboratory, you don't have such thing, because there are many factors as insulation type, equipment types, voltage levels, outdoor, indoors. So there is not like a threshold, or this is the maximum and you need to shut down.
Okay.
That's why it's important the trend follow and deeper analysis in the partial discharge. It's not only like a overcurrent relay, as you mentioned, that you need will trip. Doesn't work like that way. Okay.
Now there's an IEEE 14. I just did a quick search on IEEE's website. There's a 1434. Does that ring a bell? Is that something that is? And this says IEEE Guide for Measurement of Partial Discharge in AC Electric Machinery. So it looks like there's materials out there, and this is dated as far back as 2014 for its first publication. So it looks like it's not unique to Eaton, and it looks like it's an industry type of technology, or at least awareness of an issue.
Yeah, this technology has been in the field for a long time, but thanks to the advanced technology, now is in hand of the people. Now, do you have a handheld equipment for partial discharge,
Mm-hmm.
diagnostics? We have the Instagram, so now it's more on reach for the industry.
Okay, so now Tamaki has a question, and as an electronic engineer, I see this current probe used together with spectrum analyzers. So we all know what spectrum analyzers are, right? Does this current transformer look like probe used together with a spectrum analyzer, as well as detect the predictive diagnostic to partial discharge? What it sounded like was described is like a spectrum analyzer, because you're looking at much higher frequencies. Is this similar to that type of application?
The two different instruments can be used to measure partial discharge. Again, the partial discharge produces the electrical pulse. So you can measure this electrical pulse, for example, using oscilloscopes.
Okay.
Of course, you can measure the spectrum of this partial discharge pulse, it is a useful instrument for some research of partial discharge. But the main characteristic of the partial discharge, by the way, we have them in this presentation. Maybe you can, Jerry, to make, for example, yeah, this is right.
Which one? Which slide?
I think it's number 3.
Number 3. 1, 2, 3. This one here?
Yeah. It is a main partial discharge measurement value. Now, first of them, you can see partial discharge intensity. It is apparent power of partial discharge. Why apparent? Because nobody can measure the power of the spark inside the void. But you can measure the pulse, which will be in together with power voltage.
Mm-hmm.
So it is partial discharge intensity proportional to power dissipation by partial discharge, which destroyed insulation. Next parameter, it is maximum PD magnitude. It is highest partial discharge pulse magnitude with some repetition rate, because on the facility sometimes can be appear the high pulses, but it's maybe noise or other reason of this. So this parameter for the pulses which has some repetition rate. And historically, it is 10 pulses per second. So it is not maximum amplitude, all possible pulses you will measure, but pulses which will be not further than 10 per second. And then you can see parameter pulse repetition rate. It is number of pulses per second or per cycle. No, and very important parameter, it is trends of this parameter. Because, for example, it is known that, for example, one motor can have higher partial discharge level, but stable. Other one can have lower but not stable, which will be increased with time. So the trend, it is sometimes very important parameter, especially because there is no threshold for all equipment. You don't know what, for example, PD, acceptable partial discharge, intensity, power of partial discharge, acceptable or not acceptable. There is no definite threshold.
I got you.
Then one motor with high partial discharge can work 20 years, and other one with low but very fast progression can need to repair faster than other one.
Excellent. And would a repair be the insulation that is breaking down? So you'd have to identify what part in that system is breaking down and causing and letting that, which is causing either the pulses or the intensity to increase. Is
No, it is a question. First of all, when we see that the partial discharge strength is very high, we need to check the insulation in equipment. And for example, to see the signs of the partial discharges as powder, you can
right.
we saw before. But second task, it is to find the place where this partial discharge were originated. And it is a very hard task. And it requires to have, why it is hard? Because partial discharge, when propagated through the equipment, very fast attenuate. So you need to install many partial discharge sensors to monitor complex equipment. Not only one connected, for example, for bus in the switchgear lines, but it necessary install sensors in, for example, in each thread, partial in each thread cubicle. And you can see also that these parameters, we call them integrated, because they represent not separate partial discharge, but their integrated characteristic, power, or watts, and so on. And other parameter, it is phase reserve PD pulse distribution. You can see here the sine wave of the power and partial discharge, which occur at different phase. And the color show the frequency of the, for example, black color, it is a very low rate of this frequency rate, and red color show the very high frequency rate of partial discharge with this magnitude. For example, here red for magnitude about 30 millivolts, and this one for 200, about 250 millivolts.
I see. So across the bottom is the voltage, and then obviously up the side is your degrees.
It is phase, yeah.
Right.
And as you can read here, the shape of this partial discharge can help to detect the reason of the partial discharge. Voids, elimination, floating potential, and so on. But it is a very complex task to say what is type of defect, because usually equipment has new defects and they have different shapes. And when you saw all of them together, it's very hard to separate.
Well, how does how does somebody have to interpret this, or does the device interpret this data for them?
No, we don't have algorithm which can separate and diagnose this type of defects. It's necessary to have experience, as Raul has, for example.
Yeah,
And
typically,
he can explain better than me.
Okay.
I work on the hardware, not on interpretation of the partial discharge.
Okay,
so,
Raul.
so it is like a two-stages process. At the beginning, the equipment detects the partial discharge. It has an internal algorithm that processes it and assigns to different channels, and you get an alarm on a small LED in red. So the next step is take a look to the information stored in the InsuGuard and see what happened. Because sometimes could be real PD, for example, bus dock getting humid, or sometimes it's a switching for the breakers in other cubicles.
Right.
That could get into the InsuGuard, confuse the equipment, and it shows the alarm. So, or also could be electrical noise coming from the ground. So you need to double check that it's real PD before take any actions.
Gotcha.
That's why it's not like a green red. No, you need to take a look to the information.
So Raul, hold on though. If the data is like this and it's hard to interpret, how would a customer even know what they're looking at? Or do they? Is there like a class they take that says, okay, we're going to teach you how to this, or is this something that, as a supplier, we get the report back and help them? How does somebody navigate those waters?
Yeah, if the customer doesn't have somebody with knowledge, they will need to download information and send back to us for analysis.
Okay.
Sometimes they request us to be there and all the download process and stuff. And the third option that we'll be talking about later is the remote monitoring process. Is when we add a small hardware to the InsuGuard, and that data goes to our servers and to my desktop. Now
I get the connection. I was trying to think of what's the connection between remote monitoring and partial discharge, and the answer to that is right there, right? Because you've got to figure out how to interpret the data, and we can do that remotely with a customer. That makes sense.
That's correct.
Okay.
I have some input here.
Yeah.
Story is that InsuGuard itself has pretty flexible settings, and it could be set up to generate a warning of different kinds for the customer. And so it's pretty independent. It doesn't mean it must have a remote connection, remote monitoring, but till a certain extent.
Okay.
If there is something complex happening, or it's kind of getting constant alarms, or kind of getting warnings, or people do not understand what's going on at all, they would be probably have advantage of being able to work with remote monitoring, but some people are doing it themselves. So if the device set initially correctly, and they are once in a while coming to that to check it out, and having an interest to do that, they can do it themselves. But not many people are capable to do that. That's
Gotcha.
fair. And that's why a remote monitoring group has a benefit for those who are to the subscribers.
Yeah, and it's always great to have a qualified person, an expert that you don't have to hire them on staff. You can just say, hey, I need you to peek in and take a look at it, or periodically touch base with them. That's all. It's like going to the doctor, right? I mean, we
But some customers are kind of taking care about that themselves. Depends.
Yeah. It just depends. Like if you marry a doctor, or your daughter becomes a doctor and she's at the house.
That's easier.
It makes life a lot easier. Excellent.
I'd like to add that it is very useful. I mean, this characteristic phase resolved distribution. It is very useful. But again, I'd like to go back to the integrated parameter.
Mm-hmm.
And these parameters, partial discharge intensity or Qmax, also very important. And sometimes it is enough to see this parameter to make conclusions that it is necessary to check condition of the insulation. For example, if customer see that these parameters integrated power or Qmax increased, they can check the equipment. If it is about the switch gears, for example. Of course, if it is motor, they can check winding of this motor. So in this case, they need more diagnostic instruments, not only the integrated parameter, but this one shown the picture, and make conclusion.
I like it. And it's very important. You could use this in your maintenance schedules, and based upon the data that you have, and you can know when to pull maintenance when you start to see some abnormal conditions that might be arising. I like it.
Hey, Tom, real quick, Felix is still out there. I put in the team site, there's a really good white paper that a lot of the engineers from Eaton wrote. Felix, if you're out there, want to have some time to take.
They're not on Teams, so what you have to do is can you email?
I said in the Teams. If you can grab it and put it.
Oh, you put it in the. Yeah, hold on. Let me. What I'll do is I will grab it. I got to show conversation, so everybody's going to shift. Oh wait, no. Can you put it in the meeting chat?
Yeah, 1 second here.
Yeah, because I don't have, this is my separate computer that is not on the Eaton network, so I don't have access because our IT department says I am rogue. I am a rogue agent of communications. Yes. So while you're doing that, I would love to know a little bit more about the hardware. I mean, we know we're at above 2400 volts. And it looks like we can do this on motors, generators, transformers, and switchgear. Now, Raul, you said something about busway. Can I monitor busway, or was that just from an interference perspective?
No, yes, you can. You can install the same sensors, the red ones. They are called coupling capacitors, and you need to install those sensors in any of the ends of the bus dock, or in both. Is it too long? You will detect the partial discharge going there.
Oh, that is sweet, because I've heard of people who have had problems with bus duct before, either because of water intrusion or other things. Yeah. This can help. Can this probably if there's water intrusion, but I don't know, water intrusion over time, if it's a little, I mean.
One very common case is when the space heaters that you have inside.
Yep.
Sometimes the record trips, nobody knows. And you can detect that with partial discharge, because you will see the partial discharge increasing at noon, for example, when the sun hit and stuff. And then the customer, oh yeah, what's the record tip it off? And
Interesting.
it
Okay.
really works.
Advantages of continuous monitoring of partial discharges in rotating equipment and switchgear. He says, is that one, Jerry?
That's one of them, but this one is continuous online partial discharge monitoring of medium voltage substations. A little bit different.
Okay, wait. Is that online?
Yeah, that's in on Eaton.com. Partial discharge.
Oh, hold on. So hold on. I can go to Eaton. What did you say? Say it again.
On Eaton, was it PD?
Eaton.com/PD.
Yep.
Oh, Eaton.com/PD. There we go. Eaton.com/PD, and then got the bushing guard, insole guard. What is the relay? And you say, wait, are you saying there's a document in here that you were referencing?
Yeah, I think you go back up to the top under resources.
Go to probably click the insole guard one.
So insole. There we go. Insole guard, and then resources. Because all I'll do is I'll put that in the chat. And then you have the brochures and product specs, guides.
Yep, expand those.
Guys, it's not there. Oh yeah. Yeah.
The white paper. Microsoft Word 2016 white paper.
Yeah, pull that one up. I dropped it in your chat, but we'll see.
Is this it?
Nope.
You so you did put it in the chat?
Yeah, I put it in your chat, just you.
Okay. Show participants. Let me show this. Why don't I see it? I don't see it in my chat. Well, that's okay, because it's only the four of us on the chat. So it doesn't, but apparently, I don't know.
There we go. Try it again.
Yeah. I just put chat in there. Can you see my chat?
There it is.
There we go. Okay. I'm going to download. Everybody shifted on me, so that's okay. Download. There we go. File didn't download. I don't know why, but it didn't download. That's okay. What I'll do is I'll have to get. Too bad we don't have a link for it. I'll have to. What I'll have to do is, in any case, I can put it up somewhere and get it out as far even after the fact. So I'll share that with everybody. IT team blocked Tom's access. Rogue Tom, that's me, Mohammed. Jeez, oh man, they just don't like me. And you know what? You know why I think it is, Jerry? Because I'm outside the network. They don't want us to share files.
Yeah. Oh yeah. That's it.
Yeah.
Always watching. Always watching.
That's exactly right. That's they're always watching it. So let me ask you a question. So I can monitor busway. I can monitor motors and generators and transformers. I can sense failures and whatnot. All of this equipment is, and this is the software. So these sensors here, I would be connecting into my system. And these are what, data communications, or are these sensors as well?
It's for sensors.
Those are all sensors?
Yep.
And all of that ties? Okay.
Looks like the gray ones are for the high frequency current transformers. The small ones that Mohammed was asking before.
Yep.
That is for cables and feeders. The black ones is the black ones are the current transformers, and the gray ones is temperature and humidity sensor.
All right, RTDs. Yeah, I got you.
And load sensor also. Yeah.
Gotcha. Okay, and then all of that comes into this brain, and the brain analyzes the data. So it's technically not a relay; it's a monitoring system.
This is monitoring system. Yeah, and actually, I do not like when people call it relay because it switches the kind of the goal. It's not real.
Yep. That makes sense. Now I see this was in an enclosure, the one down on the right there. Are these mounted separate from equipment, or do you typically mount them inside of equipment, like on the doors?
Typically, this NEMA box is for outdoors installation, like in motors or outdoors switch gears.
Okay.
But for indoor switch gears, it's typically installed in a door or in the back of the door, depending what you have there.
Gotcha. All right. That makes sense. And then, okay, so this is getting into the fact that once you're monitoring the equipment, now we can connect these, and you have cell routers. I mean, this is kind of cool. Cellular connection directly to it, so it's like you don't have to network them together. They're independent units.
Yes, correct. You only add one cell phone, one cell modem to the sites or installation, and you can connect all the InsuGuards.
What do they connect? Is that RS-45 Modbus?
Correct. Yeah. You know, R485 is the best protocol out there.
Yep.
That never fails. So if the InsuGuards are close enough, you can use only one modem for all of them.
Okay, and the protocol, is it Modbus protocol?
Modbus RTU, and there is kind of binary variation that's mostly used for ours. But that's, in general, it's Modbus RTU.
9600 baud.
96 and 3, whatever it is.
38 for.
All right. Yeah. But there's no.
Yeah, so here, as you can see, in the field, you only have the InsuGuard and the modem.
Yep.
And one interesting thing is that the modem is in the Eton network. So that is for, cyber attacks, for security reasons, sorry.
Cybersecurity?
Yeah, so it's in the Eton firewall. But the only way to access the information there is if you are in the Eton network, and then goes to AT&T, and all the information is every day stored in the server in Warrendale, in Pittsburgh.
Okay, so hold on. How does a customer get that data? How does somebody who's not an Eaton employee get the data?
You need to do local connection to the InsuGuard.
Okay.
You could remove our connection and connect yours, or use an USB port or other access.
Gotcha. So this is when you have a site that has the InsuGuards, however many devices out there, that would be pulling information into our network, and then we would be able to provide that service to a customer to say, here's your monthly report or whatever it is that we could provide to say, here's what your system looks like.
Exactly. That is the heart of this remote monitoring. Get all the information together. And in the servers, we are running some algorithms checking for the data that comes, and that send me an email every morning if we have an alarm in any site. That probably is my wake-up alarm every day.
Okay.
So we know that we need to take some actions, regarding to that analysis. And then we will contact the customer if required only.
Well, that's nice. So I don't have to worry about it. It's sort of just working in the background, and you guys are running around looking at data. And when you determine that there's a problem that somebody needs to be aware of, you call the customer and let them know about it.
Correct.
That's nice.
Typically, for example, we wait for a couple of days just to see it's a steady trend.
Mm-hmm.
2 or 3 days, depending is a motor or a switchgear, and before touching base with the customer, because you don't want to knock the door every day. Hey, you have an alarm.
Right.
That's not the idea. The idea is to relieve you from that job. So something interesting. We have a customer in Newark, in the Newark airport. Is the Port Authority, I think is the name. So when this rains, you guys got up there. So I was checking for partial discharge in the bus dock.
Okay. Case, so you're looking at the partial discharge remotely in bus duct at for a customer who's experiencing the hurricane weathers and whatnot, and you can detect if there's going to be a failure.
Correct. They are not aware of that. I was like going before the alarm triggered,
Yeah.
just in case, because I had the time for that, and but luckily everything was fine, and no action was required.
That is really cool. I like that. And that's a common failure point. Bus duct, unfortunately, when it gets wet, it doesn't like it. You know,
no, not at all.
not at all. That's pretty cool, though. So, a security risk model. What the heck is that?
This is one worker that is now retired, Dave Ansaldi.
Oh, David. Yeah, I know David.
So one frequent question from the customer was, what about cyber attacks? What about the security of my network, and how they will affect, our sites?
Mm-hmm. And
he brings this, and it helps a lot. And this is a model that we use to show the customers why the InsuGuard is a risk for your installation, and why the remote monitoring is not a risk for your installation. So the analysis is that the risk is proportional to the threat, the vulnerability, and the consequences.
Mm-hmm.
So as we had mentioned before, the threat. The threat, the InsuGuard is not a relay, so we are not connected to any trip circuit.
That's right. So
if somebody get control of the InsuGuard, is not capable of trip anything on the circuit, will affect your production. So in this case, the threat is zero. About the vulnerability, we are behind Eaton firewall and Eaton network, so that makes everything harder to get there. And about the consequences, if somebody get this information, if not, you're not going to ask for ransom or something, because it's not valuable for anything else, just the customer, and wait for the annual analysis. So when you make this model, so the risk is zero when you use the remote monitoring for the InsuGuard.
Yeah. And the more I get into cybersecurity, the more I hear the terms, and it sounds like just like a 70E example, likelihood and severity. What's the likelihood of somebody being able to get to this data? And because it's on our firewall and all that good stuff, the likelihood is low, but the severity is also low because they can't to our point, to Alexander's point, it's not a relay. It's not turning anything on and off, and it's data that doesn't mean anything to anybody. So that's pretty cool. I like that.
Yeah, that is it's a very frequent question. So,
yep.
You now are showing this is the InsuGuard portal. After you have your InsuGuard and you have the modem installed, the customer want to access the information the same way we do remotely. So you will have a login information, a password to access the data from your devices only.
Okay, so they can get to their data even though they're not an Eaton employee. They can go up and securely get their information using a user ID and password.
Correct. Yeah, but this is like the server, something different apart only for this portal.
Right.
So you cannot access, going forward. So this is a way to the customer to get a more. It's not that deep information. Like the graph that Anatoly showed you before.
Yep.
You only see trends, and mostly used for maintenance, for maintenance team. Yeah, we're okay. We need to do something. And then do you have this report every month automatically sent by the server? So most the customer use is the semaphore, green, red, yellow light.
Mm-hmm.
So if you have more than 4 or 5 alarms in a month, you will get probably a yellow light. If you have too often alarms, you could get a red alarm. Yep. So that is a visual information from the customer. Yeah, you are okay. You need to take a look to it. And they use this actively for the maintenance program and the reliability analysis.
Look at that. So we'll get one report depends upon, will you get one of these per InsuGuard, or do you get a report For
Yes.
okay, one per InsuGuard.
One per InsuGuard, and they go together. For example, we have a site with 43 InsuGuards, and they will receive a package with all the information.
Gotcha. That's pretty cool. Oh, look at this. Look.
This is a case that we put there. It's a customer that was having these alarms triggering, and we let him know, hey, you need to take a look to this information. You need to stop this switch. It's a switch gear. You need to stop. Finally, they asked us to be there for the inspection, and we found this. So DPD was real occurring there.
Yeah.
And what catch on time. So that was a success story.
That is pretty cool. So you didn't have a catastrophic failure, but if unattended, it could eventually achieve an unattended rapid disassembly in the field. Yeah.
This is another case. This is very interesting. This is a motor, a 15 megawatts motor, 13 kilovolts. You can go to the trend, please. Up, yeah. This is a motor with very low PD intensity, and suddenly we have this trend change. It's no brainer, something going on there. When we take a look to the graph below, we confirm it's PD. It was occurring in the terminal box. So I would recommend to the customer to make an inspection there. But this is a air separation plant. They run consistently. They don't have time to stop the motor. So they postponed the inspection, and they had the failure.
Ooh.
Consider. 2 months later, after we let them know that I need to do the inspection, they had the failure, and so we were right.
Wow.
The InsuGuard did detect the partial discharge. We let them know, but unfortunately, due to the fault current, we don't know what was there.
Right.
But you can see the traces there.
That's pretty interesting. That's pretty cool.
The failure took 2 months.
2 months.
About timing, where we ask how long will take.
Yeah. So it gives you some sort of indication. Once you've identified a problem, it could be anytime. You really don't know, but it could be as soon as a couple months. It could be tomorrow. You never know. It depends on, all the activity and what's going on, what type of problem you have. But at least you have a pre-warning, and that tells you they could have had a planned outage and fixed it.
I'm sure they blame somebody because that, but wasn't us. We were fine.
Felix says they had a URDIF. I don't know what that is, Felix. I don't know if that's an acronym for something. Unintended rapid disassembly in the field. That's right. Yeah, URDIF. I gotta get a shirt. I gotta get shirts made up like that. Don't get me angry, else I'll have a URDIF. I love it. Yeah, and I like this is so true that you're giving the facility information to make a decision. And 9dB or 7dB, which is NFPA 7dB, is on maintenance. This can play a critical role in determining or adjusting your maintenance schedules. We just had that discussion on 7dB because we're going from a guide or a practice to a standard. And we were talking about the fact that your schedules of maintenance can change based upon a lot of different parameters that you have. And a lot of people think, well, they'll change because instead of pulling maintenance on a monthly basis, I can pull it every 6 months because I'm doing such a great job. But in reality, it may be that you're going to tell somebody you need to pull it sooner rather than later because of this type of information. So Tamaki says, does Eaton consider involving machine learning technology in this application to let computer perform the diagnosis based on the vast customer data? So we have? Okay.
As a matter of fact, yes. Currently, we're working a project with some data science in Eton, England. Yes, we are working in pattern recognition, trend analysis, in order to make our process a little more efficient.
Excellent.
In order to need less time, human time in the job, and the answer is yes. We're working on that right now.
Sweet. I like that answer. Oh, I like that answer. Sweet. All right. So we know what predictive now I understand the remote monitoring tie. I mean, geez, oh man, I was sitting there trying to think of what are they going to get to. So we understand what we're looking at, and it is a long-term experience and monitoring. We're looking at high frequencies. We're looking at the leakage, well, not leakage currents. They're high frequency events that we either accumulate or we do a trend with, and we can predict basically that there's something, we know that something's going wrong in the equipment. We just can't, and then you need to do an investigation, a physical look at the equipment to determine exactly where and what the problem is.
Yeah, definitely.
I like it.
Got it.
I like it. This I tell you what, it has always been it's always been, I never really understood Inselgard. I mean, it's been around in our company for a while, and I know I tell people about it. Oh yeah, if you're maintenance, you should have Inselgard, but I was always hoping nobody asked me, what is Inselgard? Now I know.
That's right. It's one of those best hidden secrets.
It's one of those.
The truth is, it's a really good, robust technology. It really works. It really detects. It really will help the customer to avoid catastrophic failures that will cost more time and money than just buy this Inselgard. And yeah, we have a pool of specialists like Anatoly, Alexander, myself, Brian in Ohio, that we have our eyes, in this data and looking for information to help the customers.
That's right, and it's medium voltage, 2300 volt, above 2300 volts, and it can be applied to new equipment or existing equipment, and especially if they're doing one of those retro fills or making modifications, get it in there so that what's going on with that equipment. I like it, and it'll do busway. I mean, and that is in my opinion, and that's where I hear about failures. I hear about failures in bus duct and things like that.
That section between the bus duct and the main cubicle, they are.
Yeah. I like it. I like it a lot. So, what are we missing, Jerry?
I've nothing. I think we covered it all.
My gosh,
it's a great overview. Obviously, we talked about the product, how the services, the remote monitoring services, all the different parts and pieces to the puzzle. And this is another tool that customers can use to give them a peace of mind that their electrical system is in good, healthy condition. If
somebody wanted to contact someone in our organization for information on either modernization of their facility or putting Inselgard in, where would we send them? Do I just tell them to go to the local sales office? Is there a specific?
A couple different places. If you don't have an Eaton contact, you can go right to Eaton.com, switchgear modernization, and there's some contacts on there to get a hold of us. I'm on LinkedIn, so if you want to find me on LinkedIn and reach out to me directly, you're more than welcome to do that.
So Eaton.com, you said /switchgear modernization?
Yep.
All one word? Because when I did it, it said back end fetch failed. I never saw that error before.
All right, hold on. I'm going to throw it in the chat for you.
Eaton.com. I may have spelt it wrong too. And then and Jerry Danish is on LinkedIn, and I'm out there too, so you can contact me and I can help you out. There's Eaton Modernization. I'm just going to search it. Electrical
There you go.
circuit protection. There it is. Eaton. Whoa, Eaton DC.
Oh, they changed it.
That's a no. That's a
Oh.
different CPC. Eaton EU. That's Europe. Wow. I don't know.
It's not working, the link. I don't know what's happening.
Uh-oh.
Oh, there it is. I got. I have this, and tell me if this is what you're talking about. Is this the site, Switchgear Modernization?
That's it.
All right. So I'm going to put that link in the chat box because I want to make sure that people have that. And you know, I'm a firm believer. Even if people, whatever it is, if you're thinking about it, if there's something on your mind about it, you can always reach out to us, and you get the right people involved, and saves everybody a lot of time. Here's our site. I'm just going out on my LinkedIn. There it is. And I think I have you in this note. In this, I have Michael King, but I don't have. I gotta tag you. I think I gotta do I gotta do at Jerry. I think I gotta do. I think I have to do at whatever. I don't know what they call that, but
Okay.
yeah. So I just put this link in the LinkedIn one. So at least everybody will have that, and I'll make sure that once I get done with this, I put all the links for modernization, because we still have at least one more program, or maybe more, because I'm starting to get questions now about this topic. And in fact, medium voltage is going to get attention in the National Electrical Code. They're doing a lot of reorganization of the requirements around medium voltage, and things like this and modernization are probably going to be opportunities where it's going to raise questions. So once you get more dialogue and more people talking about things, it'll be a good thing to have this information out there. So
Nope, I love it. Let's keep the ball rolling. Let's keep the focus on our group.
yeah, absolutely, because we could save a lot of lives, in my opinion, and a lot of equipment. So we had Anatoly Alexander Romushkov. Is that right? Romushkov, Raul Febres, Anatoly Celiber. Something like that. That was a good discussion. I really enjoyed this discussion. I know I learned a lot. Hopefully everybody out there learned a lot. Mohammed said great discussion. So Mohammed, thank you for joining in, and Tamaki as well. So it's morning in some parts of the globe, and it's evening in others. So it just happens to be evening in my world. Any last words, guys? Any closing thoughts, parting thoughts? Nothing?
No, the only thing I'll add is there anyone out there that needs more information or wants to get some education and learn more? Obviously, please reach out to us. We love to help.
Absolutely.
Yep.
Absolutely. All right. Well, if there's nothing else we want to talk about, and I don't have any other questions in the chat, I want to thank each of you for spending some time. And Nikolai Tesla, look at this. We bring them back. We got Nikolai Tesla watching. Man, that's a diehard right there, you know? To come back. Mohammed says we might some PD monitoring after this tornado in Pennsylvania. Oh, that's right. So everybody out there who's in the path of the tornado and all that bad weather, please get to shelter and make sure you hunker down until it's all done. Sit back and watch YouTube. We got a whole bunch of YouTube videos. We got the whole modernization week, Monday, Tuesday, Wednesday, and now Thursday. And just keep watching them over and over. You'll never believe how much you might have missed. Thank you, Felix, as well. And thank you, Tamaki. Gracias. Spasiba. Nami. Spasiba, Nami. Do svidania. Do svidania. Awesome. All right, guys and gals, thank you very much. I appreciate your time. And you guys take it easy. Stay out of trouble. All right?
Bye.
All right, thanks. All right, everybody. Thank you for joining in. And Nikolai Tesla, you're a Siemens spy. I appreciate that.
At least he's honest.
Yeah, at least he's honest. Don't worry. We'll teach anybody. And we take anybody's orders, too. That's
right.
I love
all right,
it.
I got to get in the road because my flight is at 7:40.
All right, brother.
I got to bust it. But thanks, Tom.
Sure
Appreciate
thing.
it. And I'll follow up with you next week on getting the last subject in.
That sounds like a plan. Thanks, Jerry.
All right. See ya. Yeah.
Yeah, take care. Okay, everybody, take care out there. Thanks for joining in. I appreciate everything that you guys do. Great questions. Please don't forget that I think it would be great to connect with that team and focus on modernization. Think about all of the stuff we talked about this week. We talked about taking existing equipment, changing things out, putting devices like this, monitoring, whether it be protective devices that can provide arc flash reduction, and life safety solutions to existing equipment that could be 20, 30 years old. We can take that and revitalize it and get you 30 more years out of it. So, and I hope spies follow our example. Absolutely. Yeah, we're not particular about who we work with from an education perspective, because you know one thing, I don't care who you work for. I don't care if you're with Siemens, GE, Square D, all of our competitors. One common envelope we all have is that we can all work together to save lives, regardless of our competitive natures. I think our goals have to be to try to increase safety together, so we can come together under one envelope, or one umbrella, which is saving lives. And that's what we're all about. And that's what I love about codes and standards work. That's what I love about all the stuff that we do here. So yes, you are DAF, unintended rapid disassembly in the field. I like that. I love it. All right, well, I'm going to sign off, and this is our last session this week on modernization. Tomorrow, I am doing my Q&A session at lunch, and I had another question come in on selective coordination. Oh my gosh, I just can't. It's just when you think that people understand that topic, you get similar questions, and so I'm going to try to answer that again. We're going to dig a little bit deeper into selective coordination to answer a question that came in over my email. I will bring that up. I will help whoever that was that wrote me that letter. I'm not going to raise names. I will help that person understand this topic a little bit deeper. They were suggesting maybe a code change, and there might be a need to change the definition of selective coordination. I don't know. But I'll tell you what the problem is that we're seeing in the field from engineers, very smart engineers who just don't understand the topic. We're going to dig into that. So that is tomorrow at 12 o'clock noon. And then Tuesday, don't forget, if you, Nikolai Tesla, Tamaki, if you guys and gals and cats and jammers aren't following the IAEI YouTube channel, IAEI News Live, hashtag IAEI NEWS LIVE. On Tuesdays, we go live. I'm going to have Tim McClintock, our Midwestern NEMA field representative, on with me, and we're going to be talking about resources for water damaged equipment. And again, Tim McClintock is with NEMA, the National Electrical Manufacturers Association. So we're going to be talking on the IAEI channel, not on my YouTube channel here or my sites. We're going to be talking on the IAEI's YouTube channel. Get out there for it. And we're going to be talking about resources for these flood damaged, water damaged equipment. I'll probably even bring up the smoke and fire damaged equipment too. So we're going to have, hopefully I will see you online on Tuesday for that session. All right. It is Thursday. It is Tech Thursday, and we're closing this one out. Thank you, Nikolai Tesla, Tamaki, Felix, and everybody else out there in Tubeland. Thanks for tuning in. I really appreciate it. Take care, stay safe, and Muhammad too. Remember, take care, stay safe. Please, in this COVID world, stay healthy, right? Do the right thing. Wash your hands. All right, take care. I'm going to sign off. See ya. All righty. I'm going to hit the end.